Alright student, let us start today's topic, that is monotonicity and mean value theorem. So this is the second class of application of derivatives, and in this particular class we are going to cover these two particular topics. Very easy topics, again not asked at a very high difficulty level, specifically in both the levels at CBSE, also at the JEE Mains level. So let's quickly finish this lecture and see what all variations are there in the questions for these two concepts. Let us first of all start with monotonicity. So what do you mean by monotonicity? I'll just quickly brief you about this. So monotonicity is coming from two words, right? It is coming from two words that are, one is mono and other is tone, right? And they are very easy to understand. That what do you mean by mono? Mono is nothing but one, right? So mono means one, right? No problems here. And the word tone means, it's a Greek word which means nature. So one nature is the basically meaning of monotonicity. So monotonicity, if we are going to talk about functions, there are two type of natures of graph, whether they will be increasing or they will be decreasing, as I have already drawn on the sheet, right? So monotonically increasing, what do you understand by monotonically increasing is that, if that means it should be having a single nature, that means it should be increasing. So in another way, what you should understand, that fx is not decreasing in this cases. Fx is not decreasing. This is the meaning. Okay, and here if I talk about monotonically decreasing, then the definition would be that fx is not increasing. I'll just highlight what do I mean by this, right? So that we can also go about the definitions. Fx is not increasing, fx is not decreasing. So what do you mean by decreasing first of all? So for decreasing, so as you increase the input, as you let's say increase the input, what happens to the output is actually what we are interested in, right? What happens to your output when you increase the input, whether it increases or decreases, that is what is monotonically increasing and monotonically decreasing. So if the input as the input increases, your output increases, right? Then it will be monotonically increasing. But this is not how we use the concept. What we say, that as input increases, let's say as I increases, output does not decrease. Output does not decrease, right? So does not decrease has two categories. What two categories? That it could be a constant, right? It could be constant or it could increase. Both of these categories fall into the monotonic increasing component. This is what you should understand, right? So if I say as input increases, output does not decrease, that means it could either be constant or it will increase. And similarly here I can say as input increases, right, what will happen to the output? Output does not increase. This is how we define the nature, does not increase. We do not talk about directly decreases. We do not say, we instead say output does not increase. Okay, so again here what we will say, either it will be constant, right, or what we will say, it will decrease. Both these cases fall under this particular category. Now let me show you with the help of a diagram. If you see this particular stuff over here, when I say input increases, so as layman what I can say, that input increases means as x increases. So on the number line, x increases if you travel from left to right. Okay, so if you move from left to right, that means your input is increasing. So that means in this direction you are trying to move in all these diagrams. Okay, if you say, let's say this is the first diagram and this is the second diagram. In the second diagram, if you see, as you keep on moving from left to right, the value of y is increasing all the time, right? So this is what is meant by this particular definition. As input increases, output increases. That is why I would say this is a monotonic increasing function, okay, for every value of x. So if we take any two values, let's say x2 is greater than x1 in this particular diagram, then I can say that fx2 is definitely greater than fx1, right? Now let's take this first diagram over here. In this particular diagram, if you go till here right? There is no problem. As x increases in this particular domain, the value of y also increases. Okay, but now let's take into the consideration this particular region. Here x is increasing, you are traveling from here, but your y is constant. Here y lies the same, y is constant, that is y is constant. But when I say y is constant, is it decreasing? Yes, it is not decreasing, though it is constant. Again, you see the value of y starts increasing, then it becomes constant again, then it increases again, then it becomes constant again, then it increases again. But at any point, does it decrease? It does not decrease. So this satisfies your this particular condition. That is the other condition we talked about. Either it will be constant output or it will increase. So both these diagrams actually satisfy the definition of monotonically increasing function. So if I talk about this mathematical definition over here, what you people will say, sir, as x2 increases or x increases, that means x2 is greater than x1, either fx2 will be greater than fx1 or it could be equal also. For example, if you take two x's here, let's say x1 is here and x2 is here. Okay, so what will be the condition? That fx1 is equal to fx2, right? But if you take, let's say, x1 somewhere here and you take the next x2 here, so obviously x2 is greater than x1 and the value of fx2 is also greater than fx1. So in this particular diagram, both the quantities are being satisfied. So you just have to keep in mind, for monotonically decreasing or increasing, the output should not decrease as the input increases. This is the definition of monotonic increasing function. And similarly, correspondingly, I can convert this into your monotonic decreasing graph. Let's say, if you see, as I increase my x, that is, I keep from traveling from, let's say I am traveling from left to right, that is, x increases, my value of y is getting smaller and smaller, right? So that means it is as x increases, so as x increases, y decreases in this particular case. That is why I am saying that it is monotonically decreasing. So here mathematically, as x2 increases or x2 greater than x1, what is the value at x2? Yes, it is smaller than the value of x1. This is the definition when it is increasing. Now again, if you see here, what here it is happening in this particular region, in this particular bar, right? The y is constant again, right? If you notice, the y component is same. Y is same here. Y is constant. Okay, so if y is constant, then what you would say, that let's say this is your x1 and let's say again this is your x2. So we know that x2 is greater than x1 for sure, but the values at both of them are equal. Again, no problems. Why? Because what you can see here is that we also have, they could be constant, right? So that means it should not increase. So for this region x1 to x2, it is not decreasing, it is constant. Then also I'll say it is monotonically decreasing. And again, if you see, here it is decreasing, here it is also decreasing, here again it decreases, here it becomes constant, decreases, constant, and again decreases. So here the graph is mixture of both decreasing and constant, decreasing and constant. Here it was plainly decreasing. So all these diagrams are actually monotonic in nature. For that, you have to understand what is the definition of monotonic increasing and monotonic decreasing. I am repeating it again. So monotonic increasing function is, as input increases, output does not decrease. For monotonic decreasing, as input increases, output does not increase. So in does not increase has two values, either it will be constant or it will decrease. This is how you should remember this. So if I talk about these two specific cases over here, that is the second and the third diagram, here I will call this as strictly increasing. I will call this as strictly increasing, and I call this as strictly decreasing function. Why strictly? Obviously, because here they are never equal. Here, what is the condition? As you can say, x2 is greater than x1, I know for sure that the value of the function will also be greater than at this point. Similarly, if this is the condition, this is automatically satisfied, no need to be said. So under these two brackets, that is monotonic increasing and monotonic decreasing, you have a special case, strictly increasing and strictly decreasing, where the criteria is that fx2 will always be greater than fx1, and here fx2 will be always less than fx1. Alright, I hope this conditions and the basic definition is clear, because if this is clear, I assure you that the entire chapter will be a cakewalk for you. This entire 10 minutes video is the crux of this particular chapter. So if you are not sure, revise this concept again. So let us just revise the definitions in terms of mathematical definitions. So in this particular case, right, so what I will say is x2 is taken to be greater than x1. That means x2 is bigger. I can say fx2 would be greater than or equal to fx1, because I know that here some values are constant also, right? This particular region and this particular region over here. Here what will I say, as x2 is bigger or larger than x1, is a strictly increasing function, so fx2 will definitely be greater than fx1. So this is the definition of strictly increasing. Here, as x2 is your greater than x1, since it is strictly decreasing, what I would say that fx2 will definitely be smaller than fx1, right? And for here, if x2 is greater than x1, what I can say that fx2 would be less than or equal to fx1. So these are the mathematical terms which you will use for these four particular diagrams. So if somebody asks you or ask you in a question that find the condition that it is monotonic increasing, right? Monotonically increasing. So what condition you will use if you are confused? So for monotonically increasing, both these cases are your answer, right? So the condition that you will use is fx1 is less than equal to fx2, right? As x1 is less than x2, right? And here for monotonically decreasing, what condition you will use? If you say that x1 is less than x2, then fx1 will be greater than or equal to fx2. So these are the conditions that you people are going to use for monotonically increasing or monotonically decreasing functions. Monotonically increasing, monotonically decreasing. Okay. Now let's see how you calculate a monotonicity of a particular function, right? So if you want to check at a point, what you have to do, you have to differentiate the function. So let's say y is equal to fx, your function, and you want to check its monotonicity at x equal to a. So do not get confused, though monotonicity is always a property of a point. You check for monotonicity at a point, believe me, right? So if you want to check monotonicity at x equal to a, what you people will have to do, you will have to differentiate, find f dash x at x equal to a, that is f dash a. So if it is comes out to be greater than 0, it is monotonically increasing. If it comes out to be less than 0, then it will be monotonically decreasing. In other way, I can say that if the slope of the tangent at x equal to a is greater than 0, that is positive, it is monotonically increasing. If it is the slope is negative, it is monotonically decreasing. Though at JEE Main's level, what we are interested in is in continuous graphs, right? We are much more interested in continuous curves. Okay, so there is no problem if we want to find continuous and differentiable. I should add continuous and differentiable graphs. There are cases where you will find that the graph is not differentiable. Then how you will check at f dash a? That's the problem, because we are saying the first step in this process is to find derivative. So there may be cases where I can say that fx is discontinuous, right? If it is discontinuous, so obviously it will not be differentiable. Or there might be cases that it is continuous, right? It will be continuous but not differentiable. So that how you will check at that particular point, right? So I'm just giving you a hint of how you solve this in case the problem arrives, but I do not see a problem which will come on this particular concept. So how do you check at a point monotonicity without its derivative is being known? So for increasing, right? Increasing, so we go into the limits concept here. So let's say at f x equal to a, the value of the function is fa. If the value at the left hand side is smaller and the value at the right hand side of the x equal to a is greater, So this means that at x equal to a, the function is increasing. For decreasing, if you want to check, the condition would be what? If it has to be decreasing, let us just draw a diagram. So this is a decreasing curve, right? So decreasing के लिए अगर if we check, this is x equal to a, right? So somewhere this is the left side, and this is the right side. So which value is greater? Yes, this time around the left side is greater. So what you will do, if f of a minus h is greater than fa, and instead this in return is greater than f of a plus h, then you will call the function as decreasing. So this is how you find increasing and decreasing at a point if it is not continuous or not differentiable. Just to give you an example of what I am talking about, let's see. So if this is the graph of a function where it is not continuous, can you see now this is not a continuous? I would say this is open bracket here. Okay, now somebody asks you that tell me at x equal to a where it is discontinuous, is it increasing or decreasing? So you should not get confused and say, sir, I cannot find because it is discontinuous. Increasing, decreasing or monotonicity is not a property of a continuous function. It is a property of a point. So now what we will check at, let's say, so at x equal to a, let's say the value is coming out to be a. This particular point is your value, right? This point. So let's say fa I define as a, right? Let me define this point as b, the lower one. So what will be fa minus? So somebody who is coming from a minus will report, let's say I am traveling from the left hand side, I am going, and if I ask that limiting a, what will I see? I will report, sir, I will see this particular value b. So he will report b. And what will be the value at a plus? That is someone who is coming from the right hand side. So he will report that I am just greater than a, right? Almost just greater than a or equal to a. So if you see, this condition is being exactly similar to this particular condition over here, where I can say that the left hand value is smaller, right hand value is greater than the value of the point, right? So that is why I will say at x equal to a in this particular graph, it is increasing function. Okay, so do not go into the depth of this concept. This concept is primarily going to be asked at advanced level, where we will talk about monotonicity of discontinuous functions. You just concentrate on continuous and differentiable functions. I've just given you a hint. If somebody asks you, you should know the answer and be confident about it. So if the graph is differentiable, then you just have to differentiate and check the value of the slope. If it is not differentiable, these are the two conditions that you people have to remember. Got it? I hope this condition is clear to you again. Now what will happen if somebody asks you in the interval? Okay, if from x belonging to a to b, again what we are saying that the fx is again differentiable. We will talk about the interval part only when it is differentiable. So if it is monotonically increasing, what we'll say, f dash x should be greater than 0. Decreasing, f dash x should be less than 0. If it is a constant function, so the derivative will be 0. Why? Because for a constant function, the if it has to be constant, that means y is equal to constant for some value. So y equal to constant is a horizontal line, right? If it is a horizontal line, that means the slope is, yes, the slope is 0. So if the slope is 0, that is why f dash x should come out to be 0. Strictly increasing, it should be only greater than 0. It should not be equal to 0. For strictly decreasing, it should be f dash x. It should not be double. It should be only x, right? So it will be f dash x less than 0. So this is the entire concept of this chapter. Just revise these videos, this 10 or 20 minutes video again before we go into the questions. Okay, now let's take the question. It says that the function given to you is an inverse function, that is fx is equal to tan inverse of sin x plus cos x, right? And the x ranges from 0 to 2 pi. You need to find the interval of x where the graph is increasing. Now also understand that a function need not be necessarily monotonic, right? The function can be both increasing as well as decreasing, as we can see in our sin x graph. Very easy to understand. So the sin x graph is not monotonic. Why? Because it is both, it's a dual nature, right? So let's say if I talk about from 0 to pi by 2, so from 0 to pi by 2 it is increasing. Then from pi by 2 to 3 pi by 2, it actually decreases. And again from 3 pi by 2 to 5 pi by 2, it goes on increasing. So here it is increasing, here it is decreasing, here again it becomes increasing. So this follows a tidal wave. Increasing, decreasing, increasing, decreasing, tidal wave. So we need to find the values of x for where this graph will be increasing. Okay, we know that the concept for increasing graph is that f dash x should be greater than 0. Right, greater than or equal to 0. So how you will solve this now? You just have to differentiate. So let's differentiate quickly. So it will get f dash x. What is the derivative of tan inverse x? Yes, the tan inverse x derivative is nothing but 1 plus x square. So here x role is being played by this complete function, right? Into derivative of this function will be what? Cos x minus sin x, right? And for increasing, you want this function to be greater than equal to 0. So I can say the inequality that converts is nothing but cos x minus sin x whole divided by 1 plus sin x plus cos x whole square, right? Greater than equal to 0. Now can you tell me what is the value of the denominator? It is 1 plus square. So this is nothing but a square quantity. Square is always positive. So 1 plus something positive will be positive. So I can shift it towards that side, because in inequality you can only cross multiply a positive number. So what you people will be left out with is nothing but cos x minus sin x greater than equal to 0, right? This is what you want. Okay, and if I try and solve this, this becomes cos x greater than or equal to sin x. And if you try and solve something like this, so how you will solve this? So this actually will become what? Tan x less than equal to 1, and we know that tan x, so if we think of this tan x, so what will be the answer then? Tell me quickly. So I have taken the graph here to explain you. So how do you solve this? That tan x should be less than equal to 1. So let's draw y equal to 1 line, right? Mind be, it should not, my diagram will not be a complete straight line. So y equal to 1, something of this sort. You have to check from 0 to 2 pi, and if you see that it is from 0 to this point of intersection will be pi by 4. So your answer should be something similar to what? Let's say 0 to pi by 4, right? Union, then you will say, sir, again from what? Pi by 2 to this point will be 5 pi by 4, the next point. So you pi by 2 to 5 pi by 4, right? Okay, and then what you will say, sir, again from 3 pi by 2 to 2 pi, because again it is below. So you want the points which are below y equal to 1 line. So this is the region, and then this is the region, right? So this is what you are talking about. So this will be union 3 pi by 2 to 2 pi. So this should be your answer, right? But the problem is this answer is wrong. This is the wrong answer. Now let me tell you what is the wrong. So when you say this step, this particular step is wrong over here. What you have done here, I'll again reiterate. You were here actually that cos x is greater than sin x, and then you did what? You sent this cos over here and did something like this, and then you are trying to solve tan x less than equal to 1. So here you have cross multiplied. You have cross multiplied cos x, right? Now this is only valid, this particular step is only valid when the cos is positive. So here the problem is that you have done something which is absolutely wrong. Here cos x is both positive as well as negative, so we cannot cross multiply and write something like this. So for this question to get solved, you have to solve something in this term only, where cos x will be greater than sin x. So what you will do, you will compare the graphs of both. Compare graphs of both. Right, you can solve by tan x also, but I am not getting into it because again it will be a bit complicated approach. Now draw the graph of cos and sin both on the same scale. So we draw the graph of both the functions on the same scale. So this is the picture that you people will get. So here the red graph, this graph is sin x, and this blue graph is nothing but cos x, right? You want that cos x should be greater than sin x. So in which region it is? See this part which I am shading now, this is the region where cos is greater. How you compare that which is greater? Just see which is the above graph. Now from this point to this point, red graph is above, that means sine is greater. Then again in this particular region, right, again the cos graph is above. So what you will say, that find the intersection of sin x and cos x. We know that they intersect first at pi by 4, and then next point of intersection, that is this point, is nothing but they will intersect at 5 pi by 4, at both are equal, right? Okay, so this is pi by 4. So your answer would be what? Let me just write it here. Okay, yeah, this is pi by 4. So what will happen? Let's see now. So you wanted the answer where cos x is greater than sin x. So you will reply me, sir, x belongs to 0 to pi by 4 union 5 pi by 4 to 2 pi. Now this is the answer we were looking for. In fact, it is still wrong. Why? Because you have not included the boundary points. You wanted greater than or equal to. So what your answer should look like will be something of this. So all these minor mistakes can lead to a -1 in your paper. So be very careful about them, right? So this is the particular answer we are looking for. So this is the value of x where the function is increasing, and between 0 to pi by 4 to 5 pi by 4 it will be decreasing. Now just compare it with your this particular answer that you people were getting. This much portion was right, but this does not matches. Alright, so this is a very important concept where you do not have to cross multiply a negative quantity. Got it? Okay, now let's take the other problem. It says that the function is now fx is equal to x raised to power x. You need to find the values of x where it is decreasing. Again, it's a very standard problem and you will find it in each board examination and in every institute that you might go to. Why I have taken this? Because it's something important that I have to tell you over here. Before even finding the increasing decreasing, you should check for domain. That is what I wanted to tell you. So you need to find domain. So what is the domain of this particular function? Yes, domain is that x is greater than 0. Why? Because it's an exponential function where variable is raised to power variable. In that particular case, the base should always be positive. Base should always be positive. We are not interested in finding functions where the base is negative. So you will need to find all the answers where x is greater than 0. Now if you have not applied this, your answer will come out to be wrong. Let's see how. So fx is equal to x raised to power x. You need to find f dash x. Now I can write this as, yes, I told you how to use this particular concept in the differentiation topic. So this, if you differentiate this, this becomes x raised to power x. So people who are not able to understand what I'm doing, just watch the differentiation video. Okay, and if you differentiate this, that means you have to now differentiate the power. This will become ln x plus 1, right? So this is f dash x. Now you want to check it is decreasing. So for decreasing, what you people will do is you will put it to be less than or equal to 0, right? Monotonically decreasing you want to prove. So if you are not sure about the domain, you will not be sure about what to do about this particular x raised to power x. So what I can say that as x is positive, x raised to power x will always be positive, always. Why? Because if base is positive, any power is always positive, right? Any power for that particular function will always make that positive. Here x is positive, this is positive, so this will be always positive. So in inequality, this is actually not required. You can just solve this. So if you just solve this, let's see what your answer would be then. This will be less than -1, right? And you will say, sir, x is less than or equal to e raised to power -1. And you will answer me, sir, then I can say answer is x belongs to -infinity to 1 by e, right? Now this is the error. Again, this is a wrong answer. Why? Because if you just say this, you will again fetch -1. Why? Because you have to answer in domain. Here domain was x is greater than 0. So your answer, correct answer would be that x should take values from, yes, 0 to 1 by e. This is the values of x where the graph is decreasing. And if I have to answer for the increasing part, increasing, so increasing, then x will take values from 1 by e to infinity. This is how you should answer questions like this. Got it? Okay, now let's take the other problem. It says if the range or the domain of x is given to be from 0 to pi by 2, then you want to prove that this particular inequality, that x is greater than sin x, but in turn smaller than 10x. So let's go step by step. Let us solve inequality 1 here, right? So the inequality 1 here is that sin x is less than x. This is what you want to prove. We want to prove this. Okay, so how are we going to do these kind of questions? Let me just show you a hint. So I assume a function which is hx as x minus sin x, right? Now I want this function to do something, convert this into this particular inequality. So for converting this to this, I want that hx should be greater than 0 for x greater than 0. This is what you want to prove, right? What is the value of h0 in this function? For this function, what is h0? So h0 is nothing but, see to it, 0. So in a way I can say I want to prove. So what is that to be proved? So to be proved that if x is greater than 0, hx is greater than h0, because h0 is nothing but 0. So your inequality will get proved. This is what you want to prove, right? So your target then should become that you want to prove this function a increasing function, because as x is greater than 0, function takes greater value than compared to 0. So this is the definition of increasing. So let's see what we can say. If I say h dash x, right? So h dash x would be 1 minus cos x. What can you say about 1 minus cos x? What value it can take? Cos x has maximum value 1, so this cannot be negative. The maximum or the minimum value, I should say, it can take is 0. So here you can say that h dash x is always greater than or equal to 0, and this is the definition of increasing function. So that implies if h dash x is greater than or equal to 0, hx is greater than h0, because we have taken it for x greater than 0, right? Clear? So in fact, do not get confused, we were being asked to solve from 0 to pi by 2. So I have taken a value of x which lies between 0 to pi by 2 and comparing it with the starting value. So here your answer will come out to be x minus sin x is greater than 0, and hence we can say that x is greater than sin x. And this is a very important result which you should actually remember. X is always greater than sin x. Now let's take the inequality 2 also, right? Inequality 2, you want to prove that x is less than 10x, right? And now this time around I'll take a function hx as 10x minus x. You could have taken x minus 10x also, that's not a problem. And again, if you see, the process is again repetitive. What you want to prove is that hx should be greater than 0. You again want that hx should be greater than 0. So this will get converted to what? 10x minus x greater than 0. And you will get your answer as 10x is greater than x. So let's again differentiate this function first of all. So h dash x is equal to secant square x minus 1. And we also know that secant x is always greater than 1 for x lying between 0 to pi by 2, right? Greater than 1. So this particular value will always be greater, right? In fact, you could also say it here that I can say that h dash x is always greater, because why? Because cos x will be equal to 1 at x equal to 0, which is not in the domain, right? So you can say that h dash x is greater, so it is strictly increasing. Here also it is strictly increasing. So just put the values now. So this says if this is there, that means it's a strictly increasing graph. So if strictly increasing, that means that I can say that hx will be always greater than h0, which again gives you value 10x minus x greater than 0, which in return tells you 10x is greater than x. So here it says that 10x is greater than x. Here it was sin x is greater than sin x. So if you combine all of them, you will get the relation that sin x is the smallest, then x, and then 10x, right? So remember this stuff, please. So this is a formula that you people should remember. Why I'm telling you this, can you revise the limit concept? I have taken a question which said in the limits class that sin x by x, and this is the GIF function, what will be the answer? The answer is not equal to 1 in this particular case. Why? Now you can correlate. We did that sin x is smaller than x is or in fact greater than sin x. So this particular bracket, so it is something like GIF of fraction, and GIF of fraction is nothing but 0. So that is why this was the answer, not 1. This was the logic behind this. I hope this is clear now. Okay, so the next problem says that if the function is something like this, where fx is given to be 3 cos, and this is now mod x, minus 6ax, so a is the parameter and now b is also the parameter. This is given to be that it increases for all x belonging to R. For all x belonging to R it increases. So for increases I can say that f dash x will be greater than 0 for all x belonging to R. This is what is given to you. Now you need to find the range of the values that a can take. This is your target. Okay, so we'll think of how to find a. Now let us first of all try and apply this particular stuff that we have got in the question, that is f dash x greater than 0 in the question. Before going to f dash x, we still have another problem, that there is modulus x and we do not know what is the derivative of mod straight away. So what we will do, we will split the function, as simple as that. We will write that it is 3 cos x minus 6ax plus b when x is greater than 0, and it will be what, 3 cos minus x minus 6ax plus b when x is less than 0. In fact, you will include 0 here. Okay, and now interestingly we know that cos minus x is nothing but cos x. So can you compare that these two are same functions? So in fact there was no need to put a modulus sign here. You can just replace this by x only. This is the crux of this particular problem. So this will behave something like this for every value of x belonging to R. Before going further, I would like to highlight another important function which actually behaves something like this, and it is being generally asked in the problems. For example, fx is given to be log modulus x. So then how you will solve the f dash x of this function? So again what I'll do, I'll split the log machine in two parts. So log x for x greater than 0, and this will be log minus x for x less than 0. Minded, we cannot include x equal to 0 because it is not in the domain. Now differentiate. So if I differentiate, what you will get, 1 by x for x log x for x greater than 0. And how you will differentiate log minus x? So it will be 1 upon minus x, and by applying chain rule you will also get a minus 1. So this is for x less than 0, and you can see that derivative for both of them is same, that is 1 by x. So derivative of log of modulus x is 1 by x. You people can remember this to speed up your particular calculations, because this is another very famous problem that is being asked day to day. Okay, so now coming back to our particular problem, we have got the function. Now we want to differentiate this. So what is f dash x? Yes, it will be minus 3 sin x and minus 6a, and since it is given to be increasing, so it increases, so it will be something like this. So what it will become, that 6a is less than minus, right, and a is less than minus, or let's say 2a is less than minus sin x, right? So you want this inequality. Now coming back to, you have said that f dash x should be greater than for all values of x belonging to R. So you need this inequality to be true, for every value of x, for every value of x, right, irrespective of whatever you want to do, right? So this should always be true. So you want to find a value of 2a such that this is always true, always true. Just think of this in this, this is always true. So how will you solve something like this, that this is always true? Okay, I'll reiterate for you. You want 2a to be smaller than some value. So 2a smaller than, let's say, some value here, right? You want 2a to be smaller than some value, and this some value is basically a parameter which is a changing value. So you want 2a to be smaller than some value which is ranging from minus 1 to 1, because it's a minus sign function, because this is here nothing but minus sin x, right? You want this 2a to be smaller than this value, and then it should be always true also, right? So if I say that 2a is smaller than the least value of sine function, that is minus 1, then this quantity will always be true. Because if you say that 2a is less than minus, let's say, for example, let's say LHS here is minus 5. Can you say that minus 5 will always be less than minus sin x irrespective of the value of x? If I say it is minus 4, it will be irrespective of value of x, always less. Let's say if I say it is minus 100, it will always be. But if there is a problem that I say LHS is, let's say, 0.5, then there is a problem. Then you do not know whether it will be less than minus sin x or not, because it might be possible that minus sin x will return 0.7, because minus sin x ranges from minus 1 to 1. But if it is less than minus 1, then you are sure that this particular value will always be less than minus sin x. So you want something like 2a should be less than minus 1. So the answer to this particular problem will be a less than minus 1 by 2, or we will say a belongs to minus infinity to minus 1 by 2. This is the answer we are looking for. I hope the particular problem is clear. Let us solve another problem based on the same concept. Let's see. So it says that fx is a decreasing function. So for decreasing function, what you people want, that f dash x should be less than 0. This is the given statement. Now in the fx portion, if I go ahead, fx, right, fx is nothing but minus x cube plus ax square plus bx plus 5 sin x cos x, right? So now this is something very interesting. Here it is algebraic expression, and the other portion is trigonometry. So we do not have any method to simplify it ahead, because algebra and trigonometry cannot be compared simultaneously. And the thing that you have to prove is a relation in terms of the parameters a and b, right? And we know that we have to use f dash x less than 0. So you want to differentiate this particular stuff. Let me do something. Can I say that this is nothing but 5 by 2 sine 2x, right? Multiplying it by 2 and dividing it by 2, 2 sin x cos x is sine 2x. So now let us differentiate. So if you differentiate, what it will become, minus this plus 2ax plus b, and what will be the derivative of 5 by 2 sine 2x? It will be 5 cos 2x, because 2 will get cancelled out because of the chain rule, right? And you want this particular stuff to be always less than 0. Now let us see what is happening. So here is a quadratic and here is the trigonometry, right? And if I talk about this trigo specifically, so what is the range of this trigonometric function? Cos 2x, so will range from minus 1 to 1. So this range is actually from minus 5 to 5. Okay, and this is being added to a quadratic function. So you are having a quadratic and it is adding some value here. Okay, and you want this to be less than 0. Again, always you want this to be always less than 0, because it is given that it is decreasing for all values of x belonging to R, right? So this quadratic should always be less than 0 irrespective of the value what you add here. Exactly. So for less than 0, how you can see this particular thing going on? So it could be that this is negative and this is negative. So there is no problem. It is always negative. There could be a case that there it is negative and this is positive, right? So you want that even if this is positive and this is still negative, then the case will be completely true. Can you tell me? So if this case happens, then even if you say that this is positive and the maximum positive, right? Not say just max positive, but maximum positive, and by adding maximum positive, then also the answer is coming out to be negative, then you will say that I cannot do anything about this trigonometry, but the answer is always negative. So here what I will use is that f dash x is equal to minus 3x square plus 2ax plus b, and this will be plus 5 less than 0. If this is true, then irrespective of this trigonometric function, this will always be less than 0. This is how you have to remove trigonometry from these kind of questions. Just think of it that what I have talked here, so that you can clarify yourself. There is no other way to explain this much better. Okay, so this is now a complete quadratic. This becomes a quadratic, which is you are trying to prove which quadratic which is always less than 0 for all values of x belonging to R. Now when this happens, give me an example. So this is a very good question. In fact, I would say this is the least probability that will be asked in JEE Mains level, but something of this sort, that the quadratic always passes this. So this is your x-axis. So this is that quadratic is always negative and it is always below the x-axis. So when this will happen, when a is less than 0 of the quadratic and d is less than 0 of the quadratic, here the value of a is already -3. So I am talking about for this particular, if this is the curve, don't compare the a and a over here. So for this particular quadratic, a should be less than 0 and d should be less than 0. A is already there. So you just need a condition that d should be less than 0 for this particular quadratic. So for this to happen, d is what? B square minus 4ac, right? So this will be what? Something of this sort. And this should be less than 0. Okay. Now just solve this. What you will get? 4 can be taken out common. This will become what? A square plus 3 b plus 5 less than 0. So it will be what? A square plus 3b plus 15 less than equal to 0. This is what you will get about a and b, and this is what we were asked to prove. Hence I can say proved. I hope this question is clear. Watch the video again to understand, because it's a beautiful question where it combines of trigonometry and algebra. Then we eliminated trigonometry and then we used quadratic also. A perfect question to be asked in a paper of tough level. Okay. Okay, so the next problem says that f dash x is greater than 0. That is, f dash x is greater than 0 and g dash x is less than 0. Right, these two things are given to you. So when you say that f dash x is greater than 0, so what I can imply from here, this implies that fx is increasing, right? And what I can say about when g dash x is less than 0, that gx is decreasing. So these two properties are given to you in the question. Now you are asked to select which of the 4 options is or are correct. Right, and these are all composite functions. So that is why I've said that written over here that the topic is monotonicity of or on composite functions. Okay, so now let us first of all understand what will be the behavior of f of g. Right, this is nothing but f of g composite function. So how will this function work? So there are two machines, right? We have done this in functions also. This is g machine and this is the f machine. Okay. This is f and this is g. All right. So if this machine, let's say g is decreasing, so here g is a decreasing machine and here this is a increasing machine, and you are asked what will be the net property of this composite function. Okay, now if I have to make you sure that you remember the formula, then if any of the machines in the composite function is decreasing, the answer would be, it will be a decreasing machine. As simple as that. The net machine will be decreasing. Okay, now how I will prove it to you. Let's take that two values. Let's say we are trying to solve the option A. Okay, let's talk about option A. So gx, and there are two values, gx plus 1. So which one of them will be greater? Since g is a decreasing function, so yes, so gx will be greater because this is the greater input, this is the smaller input. So the value at the smaller input will be greater than the value at the larger input. Now this you have to apply f, right? So f of gx and f of g of x plus 1, right? So here if you try and understand, here f is having input gx and here f is having input g of x plus 1. You know that this input is greater than this. So what will happen? Since f is an increasing function, so for f being an increasing function, what it will return? For increasing input, it will have increasing answer or a larger answer. For a larger input, a larger answer. So what sign you will put is this particular value. So why? Because this input, so input of f is gx, so this is greater than this input, so the value of f will also be greater. So can you see what was the original input here? So the original input that you were comparing were x and x plus 1, right? And what value is greater? the value of the composite function at x is coming out to be greater than this particular value. So that means this becomes a decreasing machine. Proved. So A answer is correct. So if I talk about f of g, that is why I said if any of the machines of f and g is decreasing, the answer would be a decreasing machine. Now let's talk about the g of f machine, right? So g of f machine is nothing but the first machine that is going to work is f, then the next machine that we are to work on is g. This will give you g of f machine, right? Clear? So let's see how it is working. So here it is increasing and again here it is decreasing. We know that x is always smaller than x plus 1, and if we talk about fx function, then fx is a increasing function. So for an increasing function, what will happen? Yes, at a larger input, a larger value. This will remain. Now g being a decreasing function, right? So now the g has these two inputs. So this is now a input. Don't worry that it is an output. Now this is an input, and now g f of x plus 1, right? Okay, so what will happen now? We know that g is a decreasing function. So for g being decreasing, the smaller the value, the larger the output. So what sign you will place this time around is this. So can you see again from here, the sign has converted to opposite sign. Again it is a decreasing function. That is what I was talking about. So just check where the decreasing machine is there. Yes, this is the other decreasing machine, that at a smaller input you are getting the larger value. So A and C are the options which are correct in this particular case. I hope the problem is clear. Again, I have taken very specific problems which are related to a particular concept. So I have converted them into a conceptual level question. So you can just remember. The formula is that if any of the machines of f and g is decreasing, the composite machine would be a decreasing function. Remember this. Okay, let us start the other chapter that we have to do in today's lecture, that is the mean value theorems. And there are two theorems that we are specifically going to cover in this chapter. One is the Rolle's theorem and the other is the Lagrange's mean value theorem, that is LMVT. Okay, so let us start with the Rolle's theorem. So for Rolle's theorem, you have three conditions which are known as its validity conditions or the validity conditions. Why? Because why I'm calling them as validity conditions? Because if any of the three is not valid, you will not be able to apply the Rolle's theorem. So that is the reason I call them as validity conditions. So what is the condition? That if you are given a function y equal to fx, where x belongs to close bracket a to b, the first condition should be that the function is continuous in a to b. It is derivable in open bracket a to b. So here boundary points have been missed out. And this is the very special condition, that if fa is equal to fb, that is the values at the boundary points are equal, then there will be a c which lies in the a and b, such that the derivative at c will give you answer 0. This is the meaning of, or this is the mathematical condition of Rolle's theorem. Now if I want to convert this into geometrical concept, right, if I want to see it by geometry, so by geometry key, I can say this is, see, this is a smooth curve, right? So it is continuous as well as derivable, right? And fa is shown to be equal to fb. So the value at a and b is both equal, and that is why they are at a horizontal line. So I would definitely get a value of x which lies between a and b, such that if I draw a tangent at this particular point, this tangent will be parallel to x-axis. So when you say that f dash c is equal to 0, this means tangent at x equal to c is parallel to x-axis. This is what I can say for sure. Okay, tangent at x equal to c is parallel to x-axis. This is what is the real meaning of Rolle's theorem. Okay. Now let us also understand Lagrange's mean value theorem before we apply them into the problems. So for Lagrange's mean value theorem, again the function is from a to b, the same stuff, that it belongs from close bracket a to b. Now it is continuous, it is derivable. Now compare this with the Rolle's theorem. The third condition is not there, where, just rewind it. So the third condition was fa is equal to fb. Now this is gone. So you can see that Rolle's theorem was a special case of LMVT, Lagrange's mean value theorem, special case. Now what this say that again you will get a value of C which lies between A to B such that the derivative at C will be nothing but equal to FB minus FA by B minus A. Okay, so this is the concept. First of all, this is the mathematical concept. Now again, if I have to convert this into geometry so that you people can understand and remember this better, what this particular value looks like, can you tell me? Doesn't it look like a slope formula? What is slope? Slope is nothing but y2 minus y1 by x2 minus x1. This is exactly what is happening. Y2 is what? This is the value is FB. This is the value is FA. So actually you get the slope of the line, AB, which is formed by joining the boundary points. So geometrical significance of LMVT is that in this particular curve, right, which is this particular curve, you will definitely get a point C, which is over here in my particular case. You will definitely get a point C where if you draw tangent, where tangent is parallel to AB. Now the tangent is parallel to AB. So this is the geometrical significance of LMVT. And if you want to convert this into Rolle's theorem, since in Rolle's theorem A and B were at equal, in Rolle's theorem what was happening? In Rolle's theorem FA was equal to FB, and if you put it this way, answer will come out to be 0. Obviously the slope will become parallel to, yes. So I can say that LMVT is the super theorem. So special case of LMVT is Rolle's theorem, where what happens is that FA is equal to FB. Now let us start applying this in questions and understand how this actually works in a mathematical way. Okay, now let's take a basic question on Rolle's theorem first of all. So this is the function which is given, and it satisfies all the conditions of Rolle's theorem in -3 to 0. So here I can say that A is -3 and B is equal to 0. So you need to find that value of C which will satisfy the Rolle's theorem condition. So it is already given that it satisfies Rolle's theorem, but otherwise if you wanted to see that x plus 3 e raised to power fx all are continuous, so their product will be continuous. All of them are differentiable, so their product will also be differentiable, since it is not getting 0 at one of them. So leave that part. You just remember that it satisfies Rolle's theorem. So if it satisfies Rolle's theorem, so our target is to find f dash c equal to 0. For Rolle's theorem, I'll just write f dash c equal to 0. So for that, what you do is find f dash x. So for f dash x, what you will do? You'll follow the product rule. And for product rule, first of all, let me simplify fx. So rather than saying this, let me say my fx is nothing but, I can say x square plus 3x, right, e raised to power minus x by 2. Now if I have to differentiate, so it will be only two terms that you have to apply the product rule. So it will become what? 2x plus 3 e raised to power minus x by 2 plus x square plus 3x. What is the derivative of e raised to power minus 1 by 2? It will be minus 1 by 2 e raised to power minus x by 2, right? Now we can take e raised to power minus x by 2 common, and this will leave us 2x plus 3 minus x square minus 3x by 2. This is what we will get, and we want to find a value of c where the derivative is equal to 0. So what you people will do is that you will equate this particular term to be 0. Okay, now we know that this particular term will never be 0 because e raised to power is never 0, right? It can never take 0, so this particular term can only be 0. So let's do this. How you will solve? 4x plus 6 minus x square minus 3x should be equal to 0, or you can say x square. What this will become? Tell me. Yes, x square minus x minus 6 equal to 0. And this is a simple quadratic which will have how many solutions? Yes, it will have two solutions. What solutions it will have? 3 and minus 2. So it will have solutions minus 2 and 3. So the possible values of C could be either minus 2 or 3. But what we will do, we'll reject the 3 because we wanted C to lie between open bracket. Let me just remove this. Yeah, C should lie between open bracket A to B. So if we talk about open bracket, that means it should lie between minus 3 to 0. There is only one particular answer which is satisfying this criteria, which is minus 2. So the answer for C is nothing but minus 2. So this is how you apply Rolle's theorem on a basic problem. Okay. Okay, now let's take a basic question on LMVT to see how LMVT works, and we'll quickly solve this particular problem. So again, it is given that there is a function fx is equal to under root of x square minus 4, and x is given to lie between 2 to 3. We know that under root function is continuous and differentiable in its domain. So we want to find a value of c under 2 and 3 which will satisfy LMVT. So for LMVT, you wanted to solve something that f dash c is equal to fb minus fa. So here it will be f3 minus, yes, this is how you solve it, fb minus this divided by 3 minus 2. Why I am doing so? Because just remember that for the LMVT, what we used to do, that f dash c should be equal to fb minus fa by b minus a, right? This is what we were to prove. So what is the value of f3? f3 comes out to be root 5, f2 is nothing but 0, right? And this has come out to be 1. So you want some value of c where f dash c is nothing but root 5. So for finding f dash c, as we did in the Rolle's theorem, let us first of all find derivative of this particular function. So what will be the derivative? This will be 1 by 2 under root x square minus 4, right, into my 2x, and if we complete this, this becomes x upon under root x square minus 4. So this is the derivative. Now you need to find f dash c equal to 0. So how you will resolve this? So you will do f dash c you want is equal to root 5. Okay, so just replace c by here. So this will be c square minus 4 is equal to root 5. Okay, and we'll square, so we'll get 5 c square minus 4, and this will be what? You can say 5 into 4 is equal to 4c square, and you will get c square is equal to 5. And we again will have two answers here, that c could be either plus or minus root 5. But again, just check where the c should lie. Yes, the c should have lied in the value ranging from 2 to 3. So the answer is nothing but c is equal to root 5. That is the answer we wanted. Minus root 5 will be rejected. So this is the simple problem on LMVT, how you apply LMVT in simple problems. Now let's take a good problem on LMVT. I should say a good one. Why? I'll let you know. So it is given that a and b are both lying between pi by 2 to 0 to pi by 2, and b is greater than a, and f is a function which is a function of both a and b, something like this. Now you want to prove that f of ab is greater than 1. So if you see, first of all, nowhere it is mentioned that you have to use LMVT or Rolle's theorem in these kind of questions. But if we check that the RHS, this particular stuff here, is something the RHS of LMVT. It is the RHS of LMVT, right? So RHS of LMVT was something like f of b minus f of a divided by b minus a. So if we compare this, then what will be the function? Just compare this with this. Yes, the function fx should be then 10x, and you are trying to solve this from a to b. Then this will become the RHS of LMVT. Got it? Clear? Now let's apply LMVT to this particular problem. So if I say f dash x, so what will be the f dash x? Secant square x, right? And what LMVT says, that LMVT will be saying that there will be a value c for which this will be nothing but fb minus fa by b minus a, or we can say it will nothing be equal to tan b minus tan a upon b minus a. What is the value of f dash c? This says that it is secant square x will be equal to tan b minus tan a by b minus a. Now coming back to the question where c, so this x is nothing but, let me replace it by c only so that you people can understand, right? So secant square c, what do you can tell me about secant square c? What is the range of secant square c? So first of all, a and b both belong to 0 to pi by 2. So c will be anything between a and b, so c will also lie between anything between 0 to pi by 2. And if c lies between 0 to pi by 2, what will be the range of secant square c? It will always be greater than 1. Can I say this? Obviously, right? So that means this particular quantity will always be greater than 1. Hence proved. This is what we wanted to prove. So sometimes these kind of questions could be asked in the paper where you will have to apply your logic and you have to make something of the mind map thing has to be done, where you always remember that this kind of thing we have studied somewhere, and then you apply the same logic using that particular concept. Okay. Now let's take a very special case of Rolle's theorem, or in fact a very different interpretation of Rolle's theorem, which is very important as per se your engineering entrance examinations. So it says between two zeros of a and b of fx, there exists at least one zero of f dash x. So if I have to simplify this, I can say that between two roots of fx lies, at least is the important word, right? At least one root of its derivative. This is the application of Rolle's theorem. Very, very important. So if you say that a and b are roots of fx, right, then there will be a c which will be the root of f dash x, where c will lie between a to b. This is what is meant by this particular theorem. So I can just explain you with the help of a diagram very quickly. Let's say this is the diagram, something like this. So this is your let me draw like a Rolle's theorem. Yeah, so this is your x-axis, right? So if this is your x-axis, then a comma 0 will be the point, and this will be what? B comma 0. And we can say that the value of fa and fb are equal and they are 0, and a and b are roots, right? A and b are roots. So what I have said, that you will have at least, so first of all highlight this step, there will be at least one. So at least one means minimum one, but there could be more than one also. So for example, I have taken more than one case. Can you see that this is parallel to x-axis? So this will be one root, let's say c1. This point will be giving a tangent parallel to x-axis, c2. Here c3, c4, c5. So can you see that tangents at all these 5 points are parallel to your x-axis because they have slope 0. So that is why, and all these of them, so c1, c2, c3 up till c5, they are nothing but roots of f dash x. This is what is meant by this. Okay, I hope the concept is clear. In fact, if you're not able to get hold of it, don't worry too much about it, because we do this concept in much detail in advance. But yes, I'll make sure that I'll take some questions so that you are able to apply them in the questions. Okay, so let's take the example on the algebraic definition of Rolle's theorem. It is given that 2a plus 3b plus 6c is equal to 0. This is given to you in the question. I'll show you how to use this. Then the equation ax square plus bx plus c equal to 0 has in the interval at least one root, at most one root, no root, or you cannot be determined. So the better option would have been instead of none, cannot be determined. So it is, you want to find how many roots this particular expression will have. Now let us start mind mapping what we just learned. So if we say that y is equal to fx have roots, let's say a and b have roots a and b, so f dash x has at least one root between a and b. That is what we just studied. Let's see how we are going to apply this and how we are going to use this given statement in the question. let's say I take a function fx which is something of this sort. I'll tell you, a by 3 x cube plus b by 2 x square plus cx. So then this will become the f dash x. Can you see now? So if you differentiate this function, you will get this. Okay, so in a way, some of you were thinking that how I have taken this function, just integrate this without taking any constant, right? Just integrate. So the derivative of this function will become this. Now if I have to apply Rolle's theorem, so validity of Rolle's theorem is that it should be continuous. So it's a polynomial, it is continuous. Since it's a polynomial, it's differentiable, no problem. Now we want to check that the value at the boundary point should be equal, that is fa should be equal to fb. What is in what interval you are trying to find? In this particular interval, so that means a is equal to 0 and b is equal to 1. You want to check whether f0 and f1 are equal or not. Now let's see that. So what is the value of f0? You put x equal to 0 here, you straight away get 0, right? What is f1? f1 is nothing but a by 3 plus b by 2 plus c. Take LCM, what you will get? 2a plus 3b plus 6c divided by 6. This is why this was given. Now 2a plus 3b plus 6c is equal to 0. So this implies this is 0. So actually this is equal, and x equal to 0, 1 are roots of fx. So then by Rolle's theorem, algebraic definitions of Rolle's theorem, I can say that f dash x will have at least one root, which lies between, at least one root lying between 0 and 1. Hence the answer is the A option. Okay, so these kind of questions are particularly famous in the entrance examinations, maybe in the BitSat or VIT or JBWE, whatever you people will take. So just understand this concept, that how we have taken this. So we have to form this particular equation that is given as f dash x, integrate it to form fx, and then try to link it with what other constraint is given in the question. Okay, I hope this question is clear. Now let's take another problem to understand again the algebraic definition of the Rolle's theorem. So now fx is given to be ax5, right, bx4 plus cx cube plus dx square plus ex. This is now given to you, where a, b, c and d are real numbers, and fx equal to 0 has a positive root. This is given that fx equal to 0 has a positive root alpha, right? And this was also given that alpha is not equal to 0. Let's see in this question. Okay, so we know that alpha is root of fx. By inspection, I can also say that there is another root. Can you tell me which one is that? By inspection, I can say, yes, x equal to 0 is the other root. Because if you directly put 0, you can say that f0 is coming out to be 0. So this implies x equal to 0 is the other root, right? Okay, so till now we have got two roots of fx. So there are two roots of fx. What are they? X equal to 0 and x equal to alpha, and we know that alpha is greater than 0. This is given because it is a positive root, and in fact I should not, it's a mistake that I have taken, that alpha should not be equal to 0 because it is already given positive. So positive means that it is not equal to 0. So just remove this over here. Okay, yeah. So now coming back, so now the first option, let's see, says f dash x equal to 0 has a root alpha 1 which lies between 0 and alpha. By this, that the roots are 0 and alpha of fx, I can easily say that f dash x will have a root, let's say alpha 1, which will lie between 0 and alpha. This is what we just studied, that is the Rolle's theorem, right? This is what is given by Rolle's. So this A option is correct. Since D option is having all of the above, so that means we need to solve for others also, right? Okay, so B says that f double dash x has at least one real root, and the C option says f dash x equal to 0 has at least two real roots. Now let's talk about this c part first. So what will be the derivative of this fx here? Let me see. So yeah, so this will be 5ax की power 4 plus 4 times bx cube plus 3cx square plus 2dx plus e, right? So what is the degree here of this? Degree is 4, that is even power. So when you have a polynomial with even power, that means it will have how many real roots? So real roots could be 4 or 2 or 0, because we know that real roots can always occur imaginary root always occur in pairs. So it could have either all 4 real roots, 2 real roots or 0 real roots. Since you have already talked about here that there is one root of f dash x, so this makes sure that there are minimum 2 roots of f dash x. I cannot tell that whether all 4 of this particular polynomial will be real, but if there is one real root of the f dash x, that means there are minimum 2, in fact I should say real roots of f dash. That is what I can say for sure, because it's biquadratic, right? So that means C condition is also true, that f dash x has at least 2 real roots. And if we talk about the B option, right? So let's say f dash x has 2 roots, 2 real roots, right? Now if you apply Rolle's theorem in f dash x rather than fx, apply Rolle's in f dash x. So the derivative of f dash x, that is f double dash x, will have at least one root lying between the roots of, yes, now you are talking. So if we apply it here, it will say that the derivative of f dash x will also have at least one root between the two roots of f dash x. So that means B option is also true. That means this is the net answer, that all of the above are correct. So this is a particular problem which I have taken, which might not be asked at the JEE Mains level. It is just to make sure that people understand the algebraic definition of Rolle's theorem. Let us take an interesting problem on LMVT, which says that fx is a function which satisfies LMVT in x belonging to 0 to 2. So there is a function y is equal to fx which is satisfying LMVT in the range 0 to 2. That means it is continuous and differentiable in this particular domain. Also given is f0 is equal to 0, and other thing that is given to you is modulus of f dash x is given to be less than or equal to 1 by 2. Now if you compare the answers, that means you are asked to find range of fx. This is your target. You are asked to find range of fx. This is the target. So how do you do this? Let's see. So I take x lying between 0 to 2. This is I know. And I start applying LMVT for y equal to fx in 0 to x, let's say. So what I can say that there will be a derivative f dash x which could be written as fx minus f0 by x minus 0, right? I can say this. Okay, so I know that whatever c value would be, so let's say if you do not want to write here x, you can say that there will be a value c which could be something like this. Let's take it this way, I have no objections here, right? This is x. So we know that f0 is 0. So if I try and solve this, become f dash c is equal to fx by x, right? Okay. Now what else is given to us? We know that modulus of f dash x, let's take modulus on all the sides first of all. So this is what it will become. Okay. Now it is given that modulus of f dash x is less than 1 by 2 for all values lying between this. So I can say that f dash c modulus is less than 1 by 2. So this reduces this particular expression to that fx by x mod is less than or equal to 1 by 2, right? let me do another particular step where I would say this is right. Why I can cross multiply mod x? Because x lies between 0 to 2. It's not a 0, or it's basically a positive number. Now if mod x lies between 0 to 2, let me write it again. So here it is 0, x lies between 0 to 2, right? Let me change the pen to highlight this. So mod x will also lie between 0 to 2 itself, right? So that's not a problem. So you are dividing this by 2, so this will now lie between 0 to 1. So that means this particular quantity will be what? Mod fx will be less than 1, right? This is your answer. That's it. The B part is your answer here. This is what we are looking for. Okay. So these kind of questions are there that are asked at maybe advanced level. I have just taken them to make sure that you are able to apply LMVT even if a tough question comes up in the paper. So by this we come to the end of this particular chapter, not chapter, in fact two subtopics, that is monotonicity and mean value theorems. I would request you people to complete the NCERT and the board textbooks that you people have to make sure that you are preparing for boards simultaneously as we do this particular topic. Okay, and I'll again be mailing the worksheet which you people can solve, work on, and that will be more than sufficient for this particular subtopic. Okay, so tomorrow we'll be covering with the maximum minima topic, which is much more difficult than the topics that we have taken today, and so I would request that you people should cover this topic by tomorrow's class. And in fact, if you have problems with the NCERT exercises of tangent, normals, error approximations, and now we today did the monotonicity and mean value theorem, just go through on the channel, watch them and finish them by tomorrow. Please follow the schedule so that the schedule is made in such a fashion that you are able to prepare for boards and JEE Mains at the same time. People who have just started to follow me, believe me, do not worry about what has been left. Start following it from today onward, right? And since we are specifically targeting first of all class 12th, so it is much more beneficial for both the top slots, that is board as well as your entrance examinations. So I see you tomorrow with a new subtopic, that is maximum minima, and then we'll finish off this particular chapter. See you tomorrow. Good night.